Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P16E2 indicates a communication error with the LIN, Local Interconnect Network, related to the Alternator Communication Group, ACG. Specifically, this code is triggered when the Powertrain Control Module, PCM, fails to receive precise signals from the alternator via the LIN connection, leading the system to log an error. In modern vehicles like the Honda CR-V 2023 and beyond, the alternator plays a crucial role in charging the vehicle's battery and providing electrical power to the vehicle's different electronic systems. The communication path for these signals runs through various components connected to the LIN system, and any disruption or failure in this path can lead to the P16E2 error being stored in the vehicle's memory. The potential causes for this DTC vary, including issues with the alternator, loose connections, or faults within the LIN circuit itself, which can all contribute to the communication failure registered by the PCM. The DTC P16E2 indicates an error in the communication between the Powertrain Control Module, PCM, and the alternator, primarily facilitated through the LIN system. The PCM is a critical electronic control unit that manages various functions within the engine and transmission systems of the vehicle. The alternator, located typically on the engine's front, is responsible for generating electrical power and charging the 12-volt battery. The LIN circuit facilitates the communication of battery status and related data between components like the 12-volt battery sensor and the alternator. When an error occurs, the PCM stores the DTC to prevent further complications. Diagnosing this issue requires inspecting both hardware connections and signaling integrity to determine where the communication breakdown is happening. Several factors may contribute to the triggering of DTC P16E2. First, a loose terminal connection, particularly at the alternator's +B terminal, can disrupt proper signaling. This is often the most straightforward issue to diagnose and rectify. If the connections are secure, then the next potential cause involves the alternator itself, which may be malfunctioning or delivering incorrect data to the PCM via the LIN. Additionally, issues within the LIN circuit, such as short circuits or damaged wires, may impair communication between connected components. Lastly, while less common, a malfunctioning PCM could also cause this code to appear, suggesting that all communication signals are being misinterpreted or ignored altogether. Identifying the exact cause requires a systematic approach that rules out each possibility. When the DTC P16E2 is logged, drivers may experience several symptoms indicating a communication failure within the vehicle's electrical system. One of the most common signs is the illumination of the battery warning light on the dashboard, which signals potential issues with charging or electrical supply. Additionally, various electronic components within the vehicle may start to malfunction or operate unpredictably due to insufficient power, affecting accessories, lights, and infotainment systems. There can also be a notable decrease in overall vehicle performance, where the engine may struggle to run effectively, particularly under heavy load conditions. The presence of the stored DTC P16E2 serves as a diagnostic prompt that appears when the PCM detects irregularities in its communication with the alternator, highlighting the need for further investigation. The first step in troubleshooting the DTC P16E2 is to conduct a visual inspection of the alternator terminal connections. This includes checking the +B terminal for any signs of looseness or corrosion, as a loose terminal is a common issue that could prompt the error code. A secure connection is crucial for efficient communication between the alternator and the PCM. If any loose connections are identified, they should be tightened or cleaned to ensure good electrical contact. Additionally, inspect other related connectors for signs of wear, damage, or corrosion, which could also lead to communication failures. Properly re-establishing these connections can often resolve the issue swiftly without further diagnostic procedures. The second step involves a detailed inspection of the LIN circuit, which is essential for transferring information between the alternator and the PCM. Begin by ensuring that the LIN BAT sensor circuit is not open or shorted. Utilizing a multimeter, check for continuity in the wires and ensure that there are no breaks or shorts along the circuit path. It is critical to confirm that there are more than 1 mega ohm of resistance in the circuit to rule out shorts to ground. This step will help pinpoint if there is a fault in the wiring or if any components connected to this circuit are causing the issue. A thorough inspection of the wiring harness and terminal connections is also beneficial to visually identify any signs of damage. In this third troubleshooting step, focus on assessing the alternator itself for signs of malfunction. Since the alternator's role is critically tied to the vehicle's electrical system, begin by measuring its voltage output to ensure it meets manufacturer specifications. Utilize diagnostic tools to evaluate the signals sent to the PCM, ensuring they reflect normal operation parameters. If abnormal outputs are found, this may indicate the alternator requires servicing or replacement. Additionally, consider checking for internal faults or component wear within the alternator. This assessment is vital, as even a minor alternator defect can lead to significant vehicle performance issues. The fourth step entails performing diagnostics on the Powertrain Control Module, PCM, to ensure it functions as intended. Start by running a DTC check using a diagnostic scanner to detect any additional error codes that may correlate with the P16E2 indication, particularly DTC P16E2. If no additional fault codes appear, further analyze the data from the components connected to the PCM. It is crucial to validate that the PCM is receiving correct signals based on the vehicle's operational state. If all input signals from connected components are normal, yet the issue persists, it may point towards a malfunctioning PCM, which would require further investigation or replacement. After conducting all necessary repairs or inspections related to DTC P16E2, it's essential to perform a final verification to ensure that the issue has been resolved. Begin by clearing any stored diagnostic trouble codes from the PCM, and then perform a thorough test drive to observe the vehicle's performance under various conditions. During this drive, closely monitor all electrical systems and their functionality to ensure everything operates smoothly without re-triggering the error code. If the vehicle operates normally without the presence of DTCs, the repairs can be deemed successful. However, if issues persist or codes reappear, further diagnostics may be warranted to explore other underlying problems. To prevent future occurrences of DTC P16E2, regular maintenance focusing on the vehicle's electrical components is vital. Begin by routinely checking the terminal connections, ensuring they are tight and free from corrosion. Inspect the wiring harnesses associated with the LIN circuit to ensure they remain intact and damage-free, as the integrity of these components is crucial for reliable communication. Scheduling periodic servicing for the alternator, including checks on its voltage output and functionality, can also spot potential issues before they escalate into more significant problems. By incorporating these preventive measures into a regular maintenance routine, the longevity and reliability of the vehicle's electrical system can be assured. In conclusion, the Diagnostic Trouble Code P16E2 signifies a communication error within the vehicle's electrical system, mainly involving the alternator's interaction with the PCM via the LIN circuit. Identifying the root cause of this error typically requires a systematic approach, beginning with simple visual inspections of the alternator's terminal connections, and progressing to detailed diagnostics of the LIN circuit and associated components. Potential causes range from loose connections to faulting alternator functionality, necessitating thorough testing and occasionally component replacements. Furthermore, integrating regular preventive maintenance measures can significantly mitigate the risk of similar issues occurring in the future, ensuring the Honda CR-V's electrical systems retain effective communication and operational efficiency. Please like and subscribe to the channel. See you next time.